In this video, I want to introduce a new force, or at least a new term for how we talk about a certain force, and that is the normal force, which is a little bit of a weird counterintuitive name, but it's actually a very simple idea. So the normal force is a force that results from two objects pressing up against each other. It causes them not to pass through each other. So basically, like if we take two objects here, like these two blocks, if I bring them together like this, and now they press up against each other, if I keep pushing them into each other, I can't pass them through each other. So why not? Well, there are deep microscopic reasons why not, but the very simple practical explanation is when I push them up against each other, they exert forces on each other at this interface between them, and those forces repel and cause the blocks not to be able to go through each other. So that's the concept of the normal force. The magnitude of the normal force, whenever I introduce a new force now, I'm going to have to tell you what's the magnitude of this force, what's the direction of this force, because those are the properties of a vector. The magnitude of this force, there's no simple formula for it. Normally, you include it as a variable in your F equals ma equations and solve for it that way. There is not just like a equation that you can plug in. Like, for instance, we did the gravitational force magnitude is mg, done. You just plug that in for the gravitational force. There isn't such a force we're going to have. There isn't such a formula we're going to have for this force. I want to say that very kind of slowly and repeatedly, because a lot of times people get in the habit of assuming that the normal force is equal to such and such, but there's not one general formula that's going to work for it. I'll show you how to handle it a little bit later. So there's no formula I'm going to give you for the magnitude. There is a simple answer for what's the direction of the normal force, and it's actually hidden in the name. I don't know if you've ever heard the word normal in a math class. Normal means, in mathematical terminology, perpendicular. That's because the normal force is perpendicular to the contact surface of the two objects pressing up against each other. So like in my example here, where we have the two blocks pressing up against each other like this, the direction of the normal force there, so say here's the first block, and here's the second block, okay, and they're pressing up against each other like that. When I say the contact surface, what I mean by contact surface is this interface where they're actually touching each other and pressing up against each other. So you can see there, when I push the blocks like this, the contact surface here is vertical. Since the contact surface is vertical, that means that the force is going to be horizontal. So the normal force, of course, it exists as a third law pair, like all forces. It's going to be repulsive, and it's going to be perpendicular to the interface between the two objects. So in this case, the normal force would look something like that. It would be a force pushing outwards on the two objects, pushing this guy to this side and pushing this guy to that side. The normal force, of course, doesn't have to be horizontal like that. If I stack the blocks this way, now the normal force is vertical. Because if I put it like this, now the two blocks are this way. I'm going to draw them separated from each other, maybe just to make the picture a bit clearer. So now the contact surface is horizontal, so the normal force will look like there and there will be the third lock there. So if I stack it like this, the normal force is holding the turquoise block up against gravity, and it's pushing the white block down with gravity. You can also even have the normal force acting at an angle. If I put the blocks at an angle like this, then the normal force is at an angle. So, you know, if my block, this one will be a little bit harder to draw on the slide because I can't rotate these blocks. Let me just see if I can do it really quickly here. So if my block is tilted like that, I'm going to quickly and messily draw this. If my blocks are tilted this way, then the normal force will also be tilted, something like that, because it has to remain perpendicular to the interface between the two objects. Okay, so the direction of the normal force is perpendicular to the contact, which is causing the normal force. So one very simple example of this would be actually the same problem I did in the video about apparent weight, because apparent weight is actually often caused by a normal force, or often measured by a normal force, or however you want to say it. So like, let's focus in on the middle case here. So let's focus on this middle case. Here, you would have the normal force pointing upward, and you would also have the gravitational force pointing downward on both of these guys. So you would have here normal force. I usually write it as Fn. Some people like to just write the normal force as N, which I find a little bit confusing because N means newtons. So then that can be a little bit confusing. Is that a unit? Is that a variable? So I use Fn. This is the gravitational force. And down here, you have both forces pointing downward. So for the top guy here, the F equals ma equation would look like Fn minus mg equals ma. So the normal force would be the object's apparent weight, mg plus ma. For the bottom picture here, though, of course, now you would have minus mg minus the normal force equals ma. So in this case, it would be minus mg minus ma. So you get something a little bit different. But anyway, calculating the normal force, we'll leave that for another video. But I just want you to know here what the normal force is, which direction it points in, and what it physically represents, so that you can know when you should include it in a problem.